Lecture 5, Predicting Quality in Healthcare, and this is the second part of this lecture. So after finalizing our data set, now we are ready to apply a model. So here, the dependent variable of our data set is a categorical variable. A categorical variable is a variable that has small number of possible outcomes. Here we have just two possible outcomes, 1 and 0. So 1 is for low quality care and 0 is for high quality cares. Okay, so as you remember, the linear regression that we had in previous lecture, it is applicable for a continuous outcome, right? So now, is it possible to apply a linear regression for this data set? So here, again, one more time, we need to predict 1 or 0 for the dependent variable, right? So we may say, yeah, we can apply linear regression, and at the end, we will round the outcome to be 0 or 1. It is possible, but it's not the best way. So here we can do better by logistic regression instead of linear regression. In logistic regression, we are going to predict the probability of poor care. So here we have the variable of y, and the probability of y gets value of 1 will be predicted. And since it's probability, and probability is a number between 0 to 1, so the probability of y becomes 0 would be 1 minus the probability of y gets value of 1. And here we assume that we have k independent variables. Then we'll have the logistic response function like this. Okay, so if you take a look at here, you see this term here is actually the linear regression equation, right? Okay, so because of that, we can say the logistic response function or logistic regression is actually a non-linear transformation of linear regression in order to have the value, the outcome, a number between 0 to 1. Okay, so yeah, the linear regression produces a continuous value, and there is no limit for that. But we want to have continuous values, but between 0 to 1, in order to interpret that as the probability. Okay, so in order to have that, we need to transform the linear regression by this nonlinear transformation, and then by having that, we will generate a number, a value between 0 to 1, and we will interpret that as the probability. Okay. In order to understand the logistic function, let's consider this term here, which is the linear regression equation in the horizontal axis here, and the vertical axis we have the outcome, the probability of y becomes 1. Okay, so the probability of having poor quality or low quality of healthcare. Okay, and then this is the shape of the logistic function. So as you see here, it takes a value between 0 to 1, and this is the shape of the logistic function. So as you see here, for the value of 0 for the linear regression equation, so here we have 0.5. So that means when it becomes 0, this term becomes 0, then we have 1 over 1 plus e to the power of 0, then will be 1 over 1 plus 1, so 1 over 2, right, or 0.5. So and as you see here, if you want to have positive value for the linear equation, then we need to have positive coefficients, right? So the positive coefficients are predictive of class 1. That means if we have more positive coefficients, that means more likely we will have higher value for the probability, and then they are somehow predicting the class 1. And if we have more negative coefficients, then more likely the probability would be less than 0.5. And so the negative coefficients are somehow predictive of class 0. Okay. So when we apply the logistic regression to our training data set, in the learning mechanism over the training data set, the coefficients are selected to predict a high probability for the poor cares, right? And predict low probability for the good care. So this is how we adjust the value of the coefficients by our training data set. Okay. In order to better understand the logistic regression, let's consider the odds. So this is the definition of the odds, the probability of low care over the probability of high care. Okay. So if odds has a value of greater than 1, that means the numerator is greater than the denominator. So the probability of low care is greater than the probability of high care. So the case of y equals 1 is more likely, right? And if the odds gets a value less than 1, that means the probability in the denominator is greater than the probability in the numerator. So that means the probability of high care is greater than the probability of low care. So the case of y equals 0 would be more likely then, right? Okay, for the odds, we have this probability of y equals 1 over probability of y equals 0, right? So here we have this probability for y equals 1, 1 over 1 plus e to the power of a negative beta 0 plus beta x1 up to xk, right? And here it will be 1 minus that. So 1 minus 1 over 1 plus e to the power of beta 0 plus beta 1 x1 up to xk. Okay, so if you simplify this fraction at the end, we will have e to the power of beta 0 plus beta 1 x1 up to xk, the one that we have right here. Okay, so this will be the odd function, and if we take the log from the both sides of this equation, we will have this. Okay, so the log of odds equals beta 0 plus beta 1 x1. So as here we could convert the logistic regression to be in the form of linear regression, and in the left side for the dependent variable we have the log of odds. So this is called the logit function. So from now on we call this as logit function instead of calling it as linear regression equation. Okay, so we call this as logit function. Okay, and this actually helps us to understand how the coefficients are impacting the value of the outcome. So by having this in terms of the linear regression form, by having the logit function, so now we can say the bigger the logit is, the bigger the probability of y equals 1. So this is actually in line with the plot that we have previously for the logistic function, and in the horizontal we have the logit actually, right? The logit function, and here is the probability of y equals 1, and as see here, bigger logit value implies the bigger probability, so close to 1. Okay. Okay, after having a brief review on logistic regression, let's get back to our data set. So in our data set, if we do some descriptive analysis here, for example, if we plot the quality of healthcare by the two variables, a number of office visits and the number of narcotics prescribed. And here for the third aspect, we are showing those by different colors. So the green color here for each dot means we have a good care, and the red dot is having a poor care. Okay, so if you take a look at this plot, you see that in this area, let me show here by different color, let's say, yeah. In this area, if you take a look at this area, you see that in this area refers to the less number of office visits and the less prescription of the narcotics, and healthcare quality is good. So by having this analysis here, we can say, okay, these two variables, I mean, number of office visits and the number of narcotics prescribed, have great impact on predicting the quality of the healthcare. So then later you will see in R, when we apply the logistic regression model, then we need to go ahead and eliminate the insignificant variables, and at the end we'll see we'll need to have just these two variables, I mean, as the significant variables, number of office visits and the number of narcotics prescribed, in order to predict the quality of health care. Okay, we will apply the logistic regression model to our dataset later in a separate recording, but for now let's assume that we have done this, and here we have our logit function as this. Okay, so as here we have two independent variables and we have positive coefficients, right? So and the intercept is a negative number, as you see here. So are higher values in these variables indicative of poor care or good care? So if we have lower values, what happens here? If we have lower values for office visits and lower values for narcotics, then the value of the logit will probably negative or less than 0, right? And then it will be an indicative of good care, right? But if we have higher values for, I mean, higher number of office visits and higher number of prescribed narcotics, then the value of logit may becomes positive, and then we are approaching to higher probability for p of y equals 1, right? And that means having low care, I mean poor quality of healthcare, right? So now we have a model, and let's see how can we evaluate the quality of our model, the performance of our model.